Welcome to EDU World Space.
We're asked to find the moment required to keep this system in equilibrium whenever an input force of 240 newtons is applied to the A position. And the problem tells us to use theta is equal to 0. So when theta is equal to 0, we can assume this input force to be applied directly horizontally. So this input force has no vertical component to it. It only has an x component. And to solve this problem, we're going to have to take the sum of moments about D, the sum of moments about the point D, set it equal to 0, and solve for that required moment to keep it in equilibrium. So next we're going to do is we're going to solve for the x component of the force applied at C. And just by looking at the free body diagram, since there's only a horizontal force inputted, we know that there's also another horizontal force at C that's in the opposite direction. So we can say that the force, the x component at C is equal to 240 newtons. And next what we're going to do is we're going to take the sum of moments about the point C is equal to 0. And we're going to solve for the y component of the force at point B. So that's going to be equal to 240 times 500 minus the y component of the force at point B times 160 is equal to 0. And solving for the unknown term, we get a value of b of y that is equal to 750 newtons. And next we're going to find the y component of the force at C. So to get this value, we can just do the y component of C minus the b component at B, the y component at B. And that will give us our value. So we do c of y. So we know that c of y minus b of y is going to be equal to 0. And we know what b of y is. So we now have c of y minus 750 equal to 0. And we now get that c of y is equal to 750 newtons. And next what we're going to do is use the formula, sum of all moments at point D is equal to 0. And we can write that as m. So we write that as m minus c of y times 300 plus c of x times 125 is equal to 0. And we know all of these values except for the moment that we're trying to solve for. So now we plug in. So we have m minus 750 times 300 plus 240 times 125 is equal to 0. And solving for the m term, we get a moment m that is equal to 100 95 Newton meters. And this is the required moment to keep the system in equilibrium.